All right, all right, all right. Shall we get this party started?
Hello, hello, hello.
Voila. Here we are. Isn't this cool? We are live, my friends, on GoToWebinar, YouTube, Facebook Live, and LinkedIn Live, all at the same freaking time.
All right, all right.
This is really cool. And now we can hear everybody's got their hit those volume buttons.
Volume's down.
Gotta hit the
Welcome.
button.
Welcome, everybody. John Barber here with Jason Cox and Dave Holdorf for Takeo After Dark in this mid-August edition in our kind of new streaming format. It's a little bit different than what we've been doing before. It was strictly webinar based, and you'd have to register and come on in. We decided, you know what? Let's try. It's been 6 years, 5 years. Let's mix it up a little bit, and we're able to live stream this on Facebook Live and all these other formats to hopefully reach a wider and different audience and give you guys out there options on how to consume Takeo After Dark. So this is our third preseason game. I like to say that we're still learning how to dot the I's and cross the T's here. Dave has been really instrumental in making this happen, as has Jason, as has Christina, our wonderful producer, who has the unenviable job of making sure that the three of us look like we know what the hell we're doing. Which I'm not going to say it was Manhattan Project hard, but it's Manhattan Project hard. That's big old kudos to Christina. We're going to be able to monitor your comments and questions, etc. while we're doing this. So we do have giveaways tonight, as Christina posted on Facebook. We do have giveaways tonight for you. So going to be kind of cool. So you will, and how do you get these giveaways, Dave? Did we decide whether we wanted to share that with anybody, or do we want it to make it a surprise?
It's 100% our discretion.
Yeah, that's right. It's
subjective.
It's completely subjective, and it's going to be based upon based upon your comments. That's right.
Based on you guys. That's right.
Yeah,
Making
you
sure
guys.
we're not the only ones talking to each other, right?
Right. You want to get a prize? You talk to us. For all the folks, we got about 20 something on GoToWebinar. If you could go to your chat function or your chat question function, just type in a hi, hello, how are you, and let us know who you are and where you are watching us from. Eric follows directions very well. The first thing he typed in was hi, hello, how are you? So thank you, Eric. Eric gets a hat. All right, I'm giving Eric a hat because Eric followed directions.
That was fast.
Eric, you are the first winner on Takeo After Dark, the new era, and you're going to get a wicked cool Takeo hat. Christina can tell you all about it. She'll get your information. So this is very, very cool. Very cool. We got Ali from Montreal. Bonjour, Ali. We're glad to have you with us. And this is excellent. Good. What do we have in store tonight, guys? Let's just talk about what we've been up to this week. And Dave, you've been a busy dude.
It never stops, man. It never stops. So it's just been doing a lot of behind the scenes stuff. So I've been working on when a lot of people consider this the next generation of training, we've already leapfrogged this too at the same time. And I've been working on a lot of VR things this week. So a lot of virtual reality when it comes to training classes and stuff. I've been doing other training classes as well. I mean, yesterday we had Takeo Tuesday as our traditional webinar series that would go on at noon. Just getting a lot of projects done, and that's only because I'm going away to play golf this weekend, so I got to get a lot.
Yeah.
All right. Very good.
Yes. Jason, what are you up to, man? Where you at?
Man, we're kicking butt and taking names out here in Colorado. We've been on a tour. I'll be in Colorado Springs tomorrow. We did 2 days back to back basic hydronics boot camps with Shamrock Sales. And next week, we're headed to more Rocky Mountain places like Salt Lake City, Jackson Hole, and Idaho Falls, all of which are one-day hydronics boot camp classes. Totally looking forward to.
Very cool. Very, very cool. I'll be teaching a class on Friday to MTTI, a technical trade school from Massachusetts. We'll be down at the factory in Rhode Island on Friday. And I love doing this.
That's this Friday?
That's this Friday.
How many students?
There's going to be 30 students plus 3 instructors.
Nice.
So this is cool. These are, you know me, how I love to mold young minds. And usually it's kind of a scary thing, but it's a scary concept. But no, this is going to work out well. No, these guys, this is terrific because these are really good dudes, good kids, good young ladies, young men that are just starting out on their journey in the trades, and I'm so excited for them because
That's awesome.
I remember being a kid starting out in this trade as well, and you don't know what you don't know, but you're so eager to learn, and it's cool. It's good. It's just fun to see them on step one of their journey, and it's a very exciting thing. So
yeah,
that's my week.
Yeah, I thought it was last week. For whatever reason, I was looking back at some old archives, and I thought I saw the date of last week that you're at the factory. So, so when I talk about where we're going to be in the next couple of weeks, I erase that on you. So make it look like you're not doing much. Yeah.
Yeah, I noticed that, but no, I'm there. And Douglas Beck says, what about moldy minds? Well, that would be mine. My mind is a little moldy at my age. It's just the way it is, But I
get a little touch of the senior citizens over here myself.
And the other,
I did, however, get my Medicare in the mail from the government. So I'm a real old man now.
Also want to let everybody know that we're also going to turn this into a podcast after we got a couple of them done here. So you will be able to consume this also on where you download your podcasts as well. So you should be that coming up online too. Soon enough. Not like I'm trying to give Christina way too much work to do. That's why we're doing this all in one shot later on.
Do we have any special guests coming up?
Once we have preseason done. So
yes.
So we're working on guests. So no guests tonight. So tonight's episode, we're going to be a little bit shorter since we don't have any outside guests joining us. So it's just going to be it's just the 4 of us are online.
Yeah, sounds like a challenge on the continent.
Man, you got 3 guys with diarrhea of the mouth here. I don't think we'll run out of things to talk about.
Yeah. So, so that's so guests will be in the future. We're still working on some schedules on that, and for those of you who are also joining us for Takeaway After Dark and expecting the old version of it, where we were doing it weekly and it was a building block of the training classes. This is now going to be twice a month. It's not going to be every other week. It is twice a month that we're doing it because it was easy for us to do Takeaway After Dark every week when we were in lockdown.
Right.
And now that the 3 of us are on the road and traveling and trying to take care of other things, it's not as easy to manage this all the time. So that's why we're setting this up every twice a month that we'll be putting together Takeaway After Dark. And it's not going to necessarily be in succession. We may have a couple of classes in succession, like tonight. We still want that training portion, and that we are following up on what we did 2 weeks ago when John was in Rhode Island and I was down in Florida. Jason,
California.
You did join us, right? Yeah, you were there.
Yep.
And, with our technical difficulties evening, but which was still worked out in the end. It started off hard, and then we got it easy as it went through there. So, it's preseason,
right? It's a preseason game.
Yep. So we had, we had talked about why Recirc 2 weeks ago, and in this episode we're going to be talking about how. All right, that we're going to get it in there, and sizing your circulator. So a little bit shorter of a class, not that 1 hour session like we normally do. It's just going to be a lot shorter. So, but still always ask questions, whether you're asking those questions on Facebook, YouTube, LinkedIn, and GoToWebinar. We're all monitoring those questions and comments coming through. We're all monitoring them. So there is no question and answer period. You got a question, you ask it right away. Whether it's something that's on that you see on the screen now, something that was on the screen 3 slides ago, and if you're really good, the next slide. So.
Yes, if you got a question on the next slide, that might be hat worthy. I'm just saying that might be hat worthy. Anyway, hey, I want to talk about our class tonight is on sizing domestic hot water recirculation pumps and why it's important. Now, let me ask the group out there, what process do you go through when you do size a domestic hot water recirc pump? Or Do you go through a process? Do you just grab a 00 whatever that you always do that's got a line cord, plug it in, and get the heck out of there? That's way more common than we like to. It's way more common than it should be, and it happens a hell of a lot more often than we realize. It works. Like we said last week, there's that I don't give a darn customer that says I don't want any excuses. I just want hot water at my fixtures with no waiting to anytime day or night, 24/7. Plug in a line cord pump and leave it alone is going to get you that. It's going to get you some other things too, and that's what we're going to go over tonight. And we're going to go over just some quick ideas on how to size that thing. And we got a comment also, on YouTube about Takeo Recirc sizer on the website. That's maybe the coolest tool, and we'll show you that as well. It's a really
I got one here on YouTube.
Really easy too.
The name is IV or LVS, said Takeo Recirc sizer on the website.
I love it.
Great. That is a great answer right there.
There you go. Very good. Very good. So let's talk about Recirc again, and it does matter. It does matter because these things that you're looking at here, these pictures that you're looking at here, these things don't just happen. Everybody knows, oh, that's just bad water. That's bad water. Oh, that's bad water, all right. But look inside the pipe. That's bad water that's hauling tuchus, if you will. It's moving, all right? It's bad water at high velocities, all right? These come from, these all come from different sources. And this is copper, of course. Copper, we know, is going to have issues with aggressive water, etc. But when you add in continuously circulating hot chlorinated water at high velocities, you're going to turn your plumbing system into a sprinkler system in relatively short order. Okay, it's not the problem with the copper. It's not the problem with the pump. It's a problem with just a bad marriage of all the ingredients. Okay, so these are the kinds of things that can happen with copper. And it's not just copper either. It's amazing what can happen with PEX tubing in certain situations. Again, hot chlorinated water running continuously at high velocities is the kryptonite for anybody's pipe. PEX, CPVC, PE, MOUSE, copper, whatever it is, it's the kryptonite for all pipe. And one of the interesting things we have seen as a kind of a slight movement in the industry is PEX manufacturers can look at a piece of pipe that's been sent back to them under a warranty claim and say, no, this failure is the result of hot chlorinated raw water running continuously at high velocities, which is outside of the scope of warranty. And then someone's having some really difficult conversations. Okay, it's not the pipe's fault. That was all that was all spelled out in the instructions. It's just what happened, okay, because of the Recirc system. So don't let this scare you about Recirc, because there are just a couple of simple and very easy fixes. So we look at this and we want to know, why is this happening? Why is this happening? One saying I read somewhere that really strikes me and stays with me. It says, when you replace "why is this happening to me" with "what is this trying to teach me," everything changes. All of a sudden, it's not like, oh my God, why is this happening to me? Woe is me. It's like, wait a minute, the universe is trying to show me, is trying to educate me. Am I willing to learn? Okay, the pipe here in this case is trying to tell us something. And it's trying to tell us that we're abusing it and it's our own fault. This is what it's trying to tell us. Let's talk about pinhole leaks and what causes pinhole leaks when we're talking about domestic hot water recirc. Okay, first thing that causes pinhole leaks, we've got elevated water temperatures, up over 140. Okay, and it's not just limited to 140. We can get down to 120, 130. I mean, that's hot water. Okay, hot water is a big part of the problem. Combine that with velocities of over 2 to 3 feet per second. Over 2 to 3 feet per second. That's another ingredient. So that water's hauling butt, okay, through that pipe. Next ingredient, chlorines, chloramines, additives, things like that the utility puts in the water, that the water department puts in the water for sanitation and things like that. Okay, so chlorines, chloramines, etc. So we've got elevated hot water, hauling butt, chlorines and chloramines, highly chlorinated water that's running continuously. Now there's four ingredients here. As installers, as service techs, as contractors, as professionals in the plumbing and heating field, we can control two of those. We can control velocities by proper circulator sizing. We can control continuous circulation by controlling it properly. Okay, those are in our control. We can deal with those. Elevated water temperatures are what they are because we got to deal with Legionella and things like that. Chlorines, chloramines, that happens before the water gets to the house. We got nothing to do with that. But continuous circulation and velocities, those are things we can deal with. So take a step back. I've always found this to be an interesting question, and I don't know if you guys have experienced this as well. What is the job of a domestic hot water recirculation pump? All right. What is the job? What's it supposed to do? I'd leave it to guys on GoToWebinar. See if you can chime in. When you put in a domestic hot water recirculation pump, what's it supposed to do? You guys out there on Facebook and LinkedIn, go as well. What is that pump supposed to do? And go YouTube, you YouTubers. What is the job? What is it supposed to do? Right. Well, it's kind of simple if you think about it. It's kind of simple. Is a Recirc pump there to deliver hot water to the fixtures? Is that its job? I'm putting it there because if I don't put it in, I'm not going to get hot water to the fixtures. Is it there to get hot water to the fixtures? That'd be a big old no from me, dog. I'll tell you what. That's a big old no. That's not its job. If you didn't put that pump in, you'd still get hot water at the fixtures. The thing is, you'd get it there eventually. Right. Eventually. Yeah, Raphael says on YouTube, he says, maintain the water heated close to the faucet. Yeah, get that hot water to the fixture as close as we can, as quickly as we can. Its job really is to keep the hot water line primed. Keep it primed with hot water so that when I open up a faucet, I'm not waiting all that long. Couple seconds for that hot water to get there. It reduces the waiting, it reduces the wasting. Okay, as Douglas Beck says on GoToWebinar, comfort and convenience. There you go, comfort and convenience. And Eric Hoffman says, save water, save energy, and increase comfort. Comfort and convenience. That's exactly what its job is. We keep the hot water line primed, so we reduce the weight and the waste. So that's what we're doing. But we've got to watch velocities. Pump sizing is critical here. And fortunately, everybody's written guidelines on that. None of this is secret. It's all out there for us to understand. This comes from the Copper Development Association's Copper Tube Handbook. In the big picture, it's one of the most boring books I've ever read. And I'm going to actually go out on a limb. I didn't read it all, okay, because I couldn't. I kind of cherry picked the important parts. But this part is straightforward. And this is about for copper tubing. We talk about right away. It talks about water velocity limitations, and right here it says in lines for up to 140 degrees F in systems where water temperatures routinely exceed 140, lower velocities such as 2 to 3 feet per second should not be exceeded. Okay, there's your velocity with water temperature. Okay. Next, locally aggressive water conditions can combine with those two considerations to cause erosion corrosion if system velocities are too high. And lastly, due to constant circulation and elevated water temperatures, particular attention should be paid to water velocities in circulating hot water systems. Okay, that's all important stuff. Both the supply and return piping should be sized so that the maximum velocity does not exceed these above recommendations. What does all that mean?
Let me interrupt you there for a second, John.
Be my guest.
So, I was doing some training classes earlier this week. I pulled up this the Copper Tube Handbook. All right, had a bunch of engineer types in the room. Not necessarily with letters after their name, but I said, yes, the most mind-numbingly boring book ever. And quite a few of the guys in the room said, it is? I've read it. I don't think, oh, crap.
That's their target audience for sure.
Yep. Yeah. So I had some guys that really enjoyed reading that book. So, yeah, in the room. Yeah.
Oh, boy. Well, you get
I was just like, oh, foot and mouth disease right there.
Now, you get the A-listers, Dave. You always have.
I I was just like, oh wow. I'm like, all right. I mean, I had a copy of it at one time. I don't have it anymore. I don't know where it is.
We took the best parts of it and we put them in our slides.
Yeah, I pulled the digital down, and that was it. Yeah.
It could be that maybe it was just me who found it mind-numbingly boring. But then again, my taste runs more towards comic books. Okay. And if it's deeper than Archie, I can't do it. Okay?
I mean, I was skimming through it because I didn't need to know how copper pipe was made. I just know it exists. So that's why I skimmed through a lot of it out myself as well. And but I did meet some guys that enjoyed the read and had a copy in their desk. So yes.
I'm glad it was you, not me.
Yeah.
All right, this comes from the Copper Development Association, and this is a chart that basically it's a maximum velocity table. All right, so we have maximum velocity for type M copper and type L copper, and notice that it's broken down into 3 different sections. There's the recirc portion, the hot water portion, and the cold water portion. What we're not limiting flow through the distribution piping to keep, to slow the water down from getting to the tub. That's not what we're talking about. The recirc pump, the only part of the piping system that the recirc pump is really dealing with is the recirc line itself. That's the only thing we're worried about. So we're going to look at that first column under maximum flow, red, where it says recirc. That's what we're going to be looking at. And here it says the maximum flow rates for half inch recirc line, 2 to 3 feet per second. We're looking at 1.6 GPM to 2.4 GPM. That's not a lot of GPM. That's a little itty bitty bit of GPM. Okay, little itty bit of GPM. 3/4 inch. This is a compelling reason to use 3/4 inch for domestic hot water recirc, because now I can go up to 3.2 GPM. All right, which is more. Okay, it'd be actually twice the flow of half inch. So we'd like to look at the 2 feet per second column and use that for our basis of design, simply because it gives us a little bit of leeway. If we go to 3 foot per second and say, well, it's 4.9, yeah, we're 5.5, close enough. That's step 1 down a slippery slope. If we deal with the 2 feet per second, 3.2, and we say, it's 3.3, 3.4, 3.5, it's going to be okay. It's going to be good. So stick with your 2 feet per second line. Now, do those numbers surprise anybody out there? That's an interesting question. Do those flow rates seem low to you? Do they surprise you? Again, we're not limiting the flow through the pipe from the mechanical room to the hot water fixture, the bathtub out there far away. We're not limiting that to 1.6 GPM. We're limiting the flow through the half inch return from that fixture back to the water heater to 1.6 GPM. That's what we're focusing on. Is that right? Now, again, if we go down to the type L copper chart below, it's going to be a little bit lower for type L copper, simply because thicker wall, slightly smaller ID. So for half inch type L copper, you can see down below there at 2 feet per second, it's 1.4 gallons per minute. Okay. So those are flow rates that we have to watch out for. Now PEX, okay, this is from the Plastic Pipe Institute. Domestic cold water piping, they give us velocity guidelines for cold water pipe. There's velocity guidelines for hot water pipe. They're talking about a maximum velocity of 12 feet per second, recommended velocity of 8 feet per second, okay, and a maximum temperature of about 200 degrees. That's for your hot water piping. And then they give us a specific set of guidelines for the recirc portion, and now we're talking about 2 feet per second. Maximum velocity of 2 feet per second through the pipe, maximum operating temperature of about 40. All right, so those are the limitations for PEX tubing, 2 feet per second, 2 feet per second. Now, what that is in terms of flow rate, it's going to depend on the size of the pipe. Okay, and then we have a chart for that, by golly. We do. Okay, we have that chart, and here it is. So half inch PEX, half inch standard SDR9 PEX at 2 feet per second, we have a 1.1 GPM limitation. Again, still half inch, but much thicker wall than copper, smaller ID. 1.1 gallons per minute. We go to 3/4 inch, it's 2.2 gallons per minute. How do we know all of this stuff? How are we going to be able to figure this out? These are nice. These are on charts, yada, yada, yada. That's that fancy book learning you guys out in California do there, Jason. Book learning stuff.
We read books that don't have pictures in them, John.
There you go. How am I supposed to know I got 1.1 gallons per minute of flow through my Recirc line when I'm in the basement and I got to put in a pump and get the heck out of here? How do I know? Well, a little bit of work ahead of time saves you a lot of grief afterwards because you will be held responsible for this. What do? We keep calm and we do the math. We keep calm and we do the math. We got a couple of questions that actually came up here. Before I get to the math and jump to the website, I do want to address a couple of these questions here. One is from, most recent one from Douglas. You are the guys who read that. No, that's not, that's a wrong question. Yeah. Why is the GPM and velocity for Recirc piping lower than the hot water piping? Again, it's continuous circulation or forced circulation through that smaller pipe. Okay. The water, go ahead, Dave.
I was gonna say the big difference is also the runtime.
Yeah, exactly. Those were the next words out of my mouth.
Okay. Yeah, it's all about the runtime. So because of the opportunity of turning a Recirc pump into an always-on pump, whereas a draw off a fixture is a short time period compared to what Recirc is doing. So that's why you see those numbers on those charts that are so vastly different from each other. Yeah, because it's short time periods, it's short spurts.
Yeah, and the flow rate, for the fixtures is to supply the fixture. That's why you size the pipe to supply the fixtures. That Recirc pipe is generally smaller, and because it's going to be forced circulation, not just normal regular gravity type flow or pressure flow that you would use to get to open up when you open up a faucet. This is forced circulation that could run, ideally not more than 5 minutes, but you run it continuously, there's your problem. So I hope that answered your question. I don't know if we danced around it or not, but I hope we got that. I hope we got that answer correct.
Sounds good to me.
So we had a great comment from Dorian over on YouTube here, and he said definitely less than what he would have thought. And that's what so many people come into when we do these training classes and we start talking about this velocity and flow issues. They're like, wow, it's a lot lower than I've ever imagined. And that's because so many systems have been oversized for so many years. And these are things that are starting to pop up on a lot of people's radar. All right. And one of those big groups is ASPE. They've been really paying attention to this. And I like to say that we've been on the forefront of this for the last couple of years, at least I know of. But of course, we can't train everybody. We're trying to. We just can't get to everybody at one time. We can't get everybody to always come by. But anytime we start talking, hey, you got to do the math to figure this stuff out. BAPs are not what you need for Recirc. So, and what John pulled up here is how to size that pump properly. So, Dorian, you're my man. You got a shirt. You got a hat out of me.
All right, Dorian. Excellent. So we've got 2 hat winners. We got Eric. Was it Eric right at the very beginning? Yeah, it was Eric Hoffman who did the hi, hello, how are you? He gets a hat. Dorian gets a hat. We got one more hat to give away tonight.
All right.
All right. So it's all up to you, my friends. This little worksheet is available on our Taco suite of apps. And it is also on our website, on the TacoComfort.com website that you can go to and use this free of charge. And it's just a way for you to size this pipe or size this pump properly and stay within the guidelines, and then know how to set it up. That's the important part that we come up with later on, and you'll see that it's really, really cool. So it starts off this just simple worksheet. Is there an existing or will there be an existing DHW Recirc line? Yeah. Okay. Yes.
That's why we're here. Yeah.
Yeah, that's why we're here. Yes.
Yeah.
There you go. Water heater type. I'm going to pick a tank type. Piping layout. We're going to do trunk and branch with recirculation. And if you're not sure what these things are, you hit that layout loop, and it'll give you a diagram of what we're looking at here. So that's just kind of helpful. Okay, just a little thing that'll help you out. All right. Supply pipe material and return pipe material. See, this is where, because sometimes you will pipe, maybe the house is piped in with copper and it's a retrofit, and after the fact they ran some PEX from that fixture back. So we broke it up into two different options. So I'm going to go with type M copper. Does that work for everybody? We're all happy with type M copper? All right, we're going to do that, and then we get down to our piping calculations. All right, and these piping calculations are basically the length, the size and the length of the supply piping, and then the size and length of the return piping. And I'm going to click on this little button here that says show details, because I'm going to show you some cool stuff here. And then you just hit this button and you start adding. Okay, first size of pipe, we're going to go 1 inch. And let's say that is 30 feet of 1 inch pipe. Okay, it's 30 feet of 1 inch pipe. All right, I hit my tab button and it tells me, okay, how many gallons of water per foot, how many gallons of water in that entire 30-foot run. No pressure drop because I haven't hooked up a return line yet. Now we're going to go with some 3/4 inch pipe. Let's add some 3/4 inch pipe, and let's say that is 65 feet. Okay, hit tab and we start populating. And then lastly, we'll go with 1/2 inch. Oops, sorry, 1/2 inch. And we'll say that's 25 feet, a 1/2 inch, getting to that farthest fixture. So right now it's telling me I have a total amount of water in that run of 3.44 gallons. Now I have to put in my return line. My return line, I'm going to put in 1/2 inch pipe. And then let's say it's 65 and 25, that is 90 and 30, we'll call it 120 feet. All right, hit my tab button. Now watch what happens. My pressure drop up here is all populated, as is the pressure drop for my return line. But also please note this line has a maximum flow limitation of 1.6 gallons per minute. 1.6 gallons per minute. All righty. Now you'll note my total foot of head loss, because now I've closed the loop. So now it's a circulator. All it's doing is circulating. So flow rate and head loss. Okay. I've got 1.72 feet ahead for my supply piping, 5.26 feet ahead for my return piping, 120 feet of 1/2 inch. Go down here and they're added together with valves and fittings. Okay, we all this is straight pipe. We have to include valves and fittings. And this 40% here is field adjustable. So let's say I want to turn that down to 25%. So basically 25% of the total length is going to be made up with fittings. It's adjustable again, user adjustable. And you'll see what I have here, 1.6 gallons per minute, 8.72 feet ahead. Do I have a mixing valve present? Let's say yes, I do. And I'm going to add another 1.8 feet ahead there. So right now I'm looking at 1.6 gallons per minute, 10.5 feet ahead. So I need a circulator that can do 1.6 GPM at 10.5 feet ahead. All right. The other thing I want to make note of is I've got 3.44 gallons of water right here in my supply line. So when that pump comes on, I got to evacuate 3.44 gallons from that supply piping and get the hot water there. So it's an interesting target to think about. So now I go down here, I see circulator efficiency type. I can go high efficiency only or standard efficiency only. Connection type, flange, sweat, union adapters. Again, I can pick what I want. This search button down here, this is where she gets cool. Brace yourself, people. This is going to be wicked awesome. Watch what happens. Hello! It's given me choices. It's given me choices. So I've got the 006E3. The Smart Plus E is the 006E3 plus the Smart Plug for control, which is interesting. All right. So let's see what this does for us, because when we click on this, it's going to give us some really cool things here. First off, when we click on that, it's going to give us the part number, specifications, links to the catalog, instruction sheet, submittal data, etc. In French and Spanish and in English. We can click here and go right to the product page on the website. But the thing that's cool, that's the coolest is this little pump curve chart right here. If I click on that, all right, it's going to show me where to set this thing up. Nice. Right there, you see that red dot. That's the duty point, 1.6 gallons per minute, about 10.5 feet ahead. If you were to look at the dial on the 006E3, all right, it's going to have minimum, which is you turn it all the way to the left, so it's running minimum speed. It's going to have maximum, turn it all the way to the right, like you're pegging the volume dial on your radio and jamming, that's going to be max. And
Turning
then
it up to 11.
Turn it up to 11. There you go, because that's one louder, you see. Then there's also a little sign for low, medium, and high. What this is telling us is you can put that dial little less than halfway between high and max. This is why we go with the 2 foot per second velocity, because there's a little leeway there. Okay, there's a little bit of leeway there. So now we know that we've got this thing set up properly for the velocity that we have for limitations. All right, we know that this is set up properly. Now I want to go back here. Our flow rate's 1.6 GPM, right? Our flow rate's 1.6 GPM. If we go back right here to 3.44, if we use the smart plug, the Takeo smart plug to control this, that's a 10-minute off, 5-minute on, 10-minute off, 5-minute on cycle. So we're not pumping continuously, but the longest it's going to run is 5 minutes, right? So I'm doing 1.6 GPM over 5 minutes. In a little over 2 minutes, I've got this line primed. In a little over 2 minutes, this line's primed and ready to rock. Okay. And I want to show you one last thing. Let me know, guys, if this is cool or not, if this makes sense. This is important because, again, someone's going to have some very uncomfortable splaining to do if you've plugged in a pump and said, hey, it works, no problem for me. Yeah. They're going to have hot water all the time.
Yeah, and if the lights dim in the house when the heat on the Recirc pump calls, yeah.
Right. But even a pump sized properly, if it's running continuously, you're pretty much going to have issues at some point, and someone has to explain why. Somebody's going to explain why. So this is the important part right here. This tells us that we can control this. Now, 1.6 gallons per minute isn't a target. It's a limit. It's a max. It's a max. Just want to show you what would happen if I said, you know what? I know I'm running for 5 minutes. All right. I'm still at 5 minutes. That's 5 gallons. I'm gonna be fine covering my 3.44. I'm gonna be fine, especially because this thing starts. It starts an hour early before it knows you're going to be taking a shower. So we've got that leeway. We've got time on our side. So if I change that to 1 gallon a minute, watch what happens to the head. The head goes down to bupkis. Okay, and that's bupkis is nothing, just so you guys know. Now we're at 4.6. Okay, we hit the search. It's going to be the same circulator, the same AC circulator, but you'll see if I go with a stainless steel or an all bronze AC circulator, I've got more choices now. Okay, I've got more choices. But let's go. I want to show you what the setting looks like. What the setting looks like with the 006E3 when we go down to 1 gallon a minute. Now we're just putting it a little bit below low. Now we're using less electricity. We're still going to be fine. We're still going to have that hot water line primed. So there's no reason not to do this at this point. 1.6 GPM is a max. It's not a target. Okay. You have the option of going lower if time is on your side. And in this case, because 3.44 gallons in the pipe, I got to evacuate that. I can do it over 5. If I've got 5 minutes on and I'm going at 1 gallon a minute, I'm gonna get her done in about 3.5 minutes.
Yeah, right? You went from about 40 watts of circulator down to about 8.
Yeah. Right.
There you go. Yeah. There you go.
So if I may interrupt you guys, Robert Jameson, cool last name by the way, YouTuber says be sure to prevent that backflow, fellas.
Oh yeah.
Right. Are we using IFCs? Are we pressing in a backflow or a check valve, or how are we doing?
With the 006E3, we have to have a check valve. There's no IFC because it's the body is an engineered composite body. We can't stick it's not big enough to stick in an IFC. So there would need to be an additional just flow check or check valve in there.
Yeah, on any circ pump.
Yep. There you go. Cool beans. I hope this is working for you guys. Let me know if this is if this makes sense. I want some feedback on, is this something that you think that we can do here? Is this Again, it's a simple process. It took maybe, because I was yakking about it, it took what, 10 minutes, but if you did it on your own, it would take about 2. Okay.
Yeah, John loves paragraphs when a single word or two.
Dave, that's my line. Okay. I can say that about you. You can't say that about me.
It's pot calling kettle black. It's pot calling kettle black.
It's been a long day today too. I'm on. I gotta refill.
There you go. There you go. All right. So we got a couple of questions out there. Wouldn't you have to allow extra Recirc time to heat the pipe as well as purging the line? Great question, Doug. That's a fantastic question. Yeah, but it also tells us why it is really important to insulate your pipe. Okay, because the pipe's not cold, it's kind of room temperature, so it's still gonna, I mean, we're what we want when we open up that faucet, we just don't want cold water, right? You know, we don't want to be washing our hands in cold. We want the water to be at least warm enough. Okay, so yeah, if we've got a little bit of extra time, in this case, we're gonna have this is why this is not an on-demand type of a system. An on-demand, you want a little bit more powerful pump because it's not going to run very long. We have time on our side here. Because remember what the smart plug does. Let's try that. Take 2 with the new mouth. What the smart plug does is when it knows you're going to take a shower, it learns, right? It learns your habits. If it knows, hey, Monday morning, Doug gets up and takes a shower at 6 a.m. I'm going to start my whole process of pulsing 5 minutes on, 10 minutes off. I'm going to start it at 5 a.m. So I got an hour window right there. Okay, so yes, you do want to be cognizant of that. It is always a good idea to insulate your pipe. It just speeds everything up. But we got an hour head start here, and even if you get up a half hour early, we're going to be okay. But yeah, I do think you definitely want to make that argument. You definitely want to put some.
Richard got me on that one,
McGrath, man. It's just a matter of time before you show.
I normally can keep my composure, Mr. McGrath, but that one got me.
There you go. All right. Other question is, running the pump continuously, is it better for comfort and consistent hot water to future? Is it a balancing act between continuous circulation and the velocity? No, I think continuous circulation is a bad idea all around. I mean, think about it. You get the velocity down, you're still running that thing continuously, and the water's still hot and it's still chlorinated. So you're buying time. Yeah. If your velocity down, you are buying time until you have a problem. Really what you want to do, in my opinion, is size it right and control it right. Okay. Now, timers are used commonly, and timers are simple. Well, unless you've tried to program one. Timers are cheap. I'll give them that. And somebody's got to program it. But the problem with timers is A, what happens when there's a power outage? Who goes back and resets them? And B, what happens twice a year when you go from daylight savings to standard and then standard to savings time? Nobody ever goes back and reprograms those. The cool thing about a smart plug, I got it right that time, Rich. The cool thing about a smart plug is that it automatically updates itself. It automatically adjusts to changes. So that's pretty darn cool. That's pretty darn cool. So there, it's a simple little thing. Once a smart plug learns a schedule, does it do the same thing every day? No, it has a daily schedule. So it takes the first week you put it in, it spends that first week learning every day. All right. And then the following Monday, it says, okay, last Monday we did this. This is what we're going to do. Last Tuesday we did this. This is what it's going to do. So it is a 7-day learning schedule. It's not the same thing every day. It's 7 distinct days, but it's constantly relearning as well. And it has cool things like a vacation mode. If it does not sense any hot water usage, because there's a sensor that goes with it. If it doesn't sense hot water usage for 36 hours, Dave? I think it's 36 hours. It presumes nobody's home. And it's going to go it's just going to turn off and have an exercise mode, and it'll restart, go back into its learning mode the next event, the next time you come home and turn on the hot water. So there you go. Could you add a Wi-Fi override for times that when you are off schedule? No, good question. No, there's nothing Wi-Fi in there, and I don't think we have any plans to add that. In instances where there's no schedule whatsoever, like my house, no schedule, right? We work from, anybody works from home, no schedule whatsoever. There is a 24-hour pulse mode that you just press this little button on the bottom and it goes into pulse mode, and it does 5 minutes on, 10 minutes off, 5 minutes on, 10 minutes off, 24/7, which is better than running continuously. Okay. So if you've got one of those customers that says, I don't care, I don't want any of your excuses, I just want me to have hot water every time I turn that faucet on, no questions asked. Okay. You could plug in the pump 24/7 and then explain to him in a couple of years why he's got a sprinkler system in his house, or you could put in a smart plug and just interrupt the flow long enough to protect the pipes while keeping the velocity under control. So your call. But I think they'd find that to work just fine. Cool. All righty. This was fun, wasn't it?
Sure.
It was,
absolutely.
Man.
Yeah, I told you I could keep going, Dave.
Oh, I know.
We're going to get out of here early, and I'm thinking, oh no, we're not.
I was actually trying to limit you too, so.
Here we're doing fine.
There you go. All right, so keep
Richard got me on that comment, man. I'm immature, dude. I am so immature.
All right, hey, we got some picks from the field. Dave, you want to take over?
We did. So yes, last time we got a submission from Picks from the Field, and for those of you that are joining us for the first time and you're not sure what this is, Picks from a Field is for us a way for us to say thank you for buying some Taco products, installing some Taco products, and sharing those pictures with us as well. So that's the really big thing about it. We love to see your work out there, and we want a lot of people to share that stuff with us as well. So do not hesitate. But just in sharing it, lots of people will share stuff and tag us on all the social pages as well. But we want to make sure that we recognize you too at the same time. All right. So send those pictures to us that are out there. So on the next slide, you will see a little bit of information about it, what we're going behind there, and also a QR code. So if you have some job sites you want to share with us, please do. So John, if you want to forward, that'd be great. Since unless you are.
Hold on. What have I done? Here we go. Okay.
All right. Just hit the space bar.
Sorry, I was responding to a question.
I got to keep you guys separated, man. I'm glad I'm in the middle.
So yeah, so that QR code that you see right there, we want to celebrate what you guys are doing out there. So make sure you share. So take a picture of that, send us some of your photos, and we're going to reward you. We're going to get you some 500 bonus points, and just recognize the greatness that you guys are doing out there. So that's always the great thing. That's what I love the most about Picks from the Field right now is celebrating everybody out there doing their stuff. So we got a submission from the last class that we had done.
Wow.
So this was a project from CRD Plumbing and Heating. They are based in Massachusetts. And you'll also see the logo on the right-hand side from DMC Electric. These two guys, I've met them a few times. They do work side by side a lot. And this was an installation that's a duplex. So when you're starting to stare at it for a second, you're like, wait a minute, what's going on here? So they had a duplex with two different heating systems going on there. So they piped it up in one boiler room, which I thought was really cool. And I think the next slide, you'll see a little blow up, same QR code if you guys want to upload anything. So got to expand up so you can get nice and close and see everything that's going on there, because there was a lot of stuff that was out there. I was trying to get Mike from CRD to come online with us tonight, but it was just been a busy week or so. So you do see a couple things. So he has a singles, and I was trying to get on the line with him, and he's just been banging out lots of job sites right now, getting ready for the heating season, which is amazing. You know, getting those boilers done now. Don't wait till the end. So that's a lot of his customer base out there. So I think this job had a couple of zone valves on it. Not sure. So on the left-hand side, you'll see the one duplex coming in. And then on the right-hand side, he's got it broken out into three circulators here. So he did have the older -4 controls on the left-hand side, and we had the new -5 on the 3-zone system on the right-hand side. So I was taking a look at the picture here for a second, and I was just like, I can't believe he got this much stuff done on this size board. I mean, that board's got to be about 6 feet wide. tops, right? And I know some guys will say, well, you should have put a hydro separator in there. I just don't see the space for it. You know, it would have been tight to try to squeeze it in here, as well as the gas pipe coming in here. The electric company did a great job from DMC. When you look at some of
Was that all low? Did they do all the low voltage?
And the line voltage.
Okay, cool.
So, and here's what's cool, right? The new -5 controls that we incorporated those back knockouts. So therefore, he went behind this wall with his line voltage to the circulators and into the new control.
Yeah, that's clean. You know what he did too? We know what he did too is he offset his connection to the air sep for his expansion tank. He went into the wall, offset, came down to keep them separated a little bit. How cool is that?
I know, right? I mean, just instead of crossing pipes and trying to figure out what's going on, I bet if you go behind the wall, it's scary.
No, he's got to be perfectly plugged.
Yeah.
That's all PEX. It's all PEX spaghettios behind the wall.
Yeah, old speaker wire that he had laying around. No, kidding, of course. I'm kidding.
We're kidding. No, it's gorgeous work.
Yep. And I see a couple things. He did throw in a mag dirt separator over here. So I'm going to assume the right side project probably has a little bit of cast iron involved, where the left side probably not so much. So he didn't throw it in there because he knows we have that bio barrier built into the circulators. So I bet you he had some cast iron in here, and it looks like we may have some isolation relays also thrown on top here. So a lot of stuff going on the project on the right.
Where is this?
To the left. This is Massachusetts.
Okay.
Yeah, so not too far from the company. Not too far from us.
I got to tell you my absolute favorite thing here.
What's that?
Any guesses?
Let's see.
And you guys out there in the real world, any guesses? My absolute favorite thing on this picture, in this picture. It's not Takeo. It's not Takeo.
The lit holder in the middle.
The lit. No, that's pretty good though. I do like that one.
Yeah. Okay.
As built. Okay. I don't know. I couldn't take a guess.
The expansion tank holders. I love me some expansion tank holders. Those things are great. What a brilliant idea. What an absolutely brilliant idea. Just cleans things up and I think it's terrific. That's just terrific.
Yep.
And it makes pumping away easier. Another topic for another day, perhaps.
Yep.
We were discussing this earlier. Facebook groups every week. It seems like every week, some hydronics Facebook group blows up when people are talking about where's the pump go, return or supply, and it just boom. But that's just. Sorry, I didn't mean to hijack the conversation, Dave. You were going with picks from the field.
No. This is a conversation for all of us. So definitely.
This is a new format, I thought.
Yeah. I like being able to everybody's got their own opinions, right? When it comes to a boiler room and how you're going to pipe it out, how you build it out, stuff like that. So a lot of different ways to do it. So I know so many guys are going after and girls are going after hydro seps. It kind of cleans it up. These guys here, they went with the closely spaced tees. And I understand why, right? I mean, we've done many classes on, closely spaced tees, hydro separators, or buffer tanks. Which way you're going to go? Right. And there's a lot of variables that come into play, and sometimes that space comes into a big portion of it as well.
Yep.
So great looking project. Really like it. Thanks for sharing it with us. Greatly appreciated. And I know that we've already been in contact back with Mike and the guys over at CRD and DMC, and thanks for the submission. So for those of you that are out there that do want to add some photos and you want to send some stuff to us, make sure you take a look at that QR code, get in contact with us, and share your work with us. Awesome stuff.
Terrific. And Richard says, my head will explode if one more guy says pumping away means from the boiler. No, it's not from the boiler. It's from the point of no pressure change. And I'm looking at this and I'm thinking, okay, the expansion tank's way down there. Where are we pumping away from? And then you just look at the air separators, and you can see the pipe from the bottom of the air separator going to that mystical world behind the wall.
Mm-hmm.
We don't know what happens to it then, but I got to believe it comes out right there, right above the expansion tank. So that's the point of no pressure change, and CRD is pumping away from it, which is a good thing.
Awesome. And you know, it's not limited to just our residential job sites either. So we do want to see some of the big stuff as well. Now, the three of us online tonight, yes, the big stuff looks impressive, and we don't know what it does. Yes, I know water goes in one side of the pumping, comes out the other one. That's why we got our other crew for doing the commercial side of things.
Yeah. Our motto is, if we can't lift it, we don't train on it.
I love it.
Yeah, if you need a piece of equipment to lift it, yes, it's another story.
It's someone else's job.
So, but yeah, you can share with us also your commercial projects as well.
Absolutely.
Excellent. Great. Dan Holohan's book is the Bible of our stuff, man. Yeah, says Robert Jameson. Yeah, I mean, when you talk about pumping away, Dan literally wrote the book called Pumping Away. But the thing I love about Dan is he'll tell you he didn't come up with it. It's not his technology. It's not his insight. He said his skill is to just gather very sophisticated, complicated theory and information, and drill down to the basics and make it understandable. Because if you tried to read, if you ever had a chance to read Gil Carlson's 1964 paper, engineering white paper on pumping away, your head will explode. Because I'm like, I need it. Explain it to me like I'm 5, because that's what I need. And Dan explained it to me like he was 5, and I thought that was cool.
Yep. Dan was the guy to put it down on paper.
He put it in book form.
Yeah.
Gil put it on.
Yeah.
Well, actually, technically speaking, if you really want to get into trivia, go back to the 30s. They were writing about the point of no pressure changing and pumping away back in the 30s, because not long after Homer Thrush first invented the circulator, all right, and they stuck it on a system, they figured this out pretty quick.
Right.
It's just that there were a lot of other things that got in the way over the years that meant some changes had to be made.
And because of the circulators that we used back at the time, and residentially anyway, it wasn't a topic of conversation, because you only had that one pump to use. So it didn't really make a difference where you put it. It was on the return for convenience more than anything. So, but it could have worked on either side, didn't make a difference, still gave you heat. So that's the biggest thing in regards to that. So, yeah.
Interestingly, people to this day will say putting the pump on the return side is wrong, meaning it's wrong and it won't work. And history and experience tells us the complete opposite. There are millions of systems out there that have had circulators on the return for decades, and they work just fine, right? They work just fine. Why is that? They were low head circulators, low head pressure differential, and they didn't create any issues. All right. We go back, and if anybody wants to learn this, we've got a lot of stuff online, and this will be a future presentation, I think, on why it's okay. But
heck yeah.
It has to do with head pressure differential and how that interacts with the point of no pressure change. But low head circulators like the BNG 100, Takeo 110, the Red Baron, all those others, high flow, low head, really flat curve for systems that didn't need a lot of head loss or head pressure differential, work just fine with the circulator on the return, and will work forever with the circulator on the return. The minute you put a high head circulator in place of that, you got trouble, my friends, right here in Flow Rate City. All right. You got trouble. And it's a self-inflicted wound. You created your own problem. Then you either, I've got to move that pump all the way on the supply where it belongs. No, you just take the wrong pump out, put the right pump in, and that's what it's all about.
Do the hydronics pokey.
The hydronics hokey pokey, man.
So anyways, a couple things I want to add to everybody out here tonight. So from our producer, she was also saying that any installs that are sent in tonight from picks from the field, automatically get a hat. So it's got to come in tonight. All right.
There's that QR code, boys and girls.
Yep. So send some stuff
or lose it.
You got some job sites you want to share? Let us know. All right. Ives from YouTube also mentioned one of my personal favorite books that Dan Holohan also wrote. Yes, he wrote The Pumping Away, and a lot of people have read that book. But Just Add H2O.
Oh yeah, excellent book.
Yeah, that's one of my favorites that he wrote. It's how to talk hydronics to people that are not in our industry. As
okay.
Doug was talking about earlier before, he's talking about us being hydronic nerds, and Rich was talking about that too. Yeah, we are, man. Right? But one of those things that's tough is how to talk hydronics to somebody else. And that's what I thought H2O did,
Mhm.
was how to talk hydronics to your customers, to not sell them. I don't want to sell somebody something, but I want to give them something. That's the biggest thing, right? Those of us that live in the world of hydronics, we want to give them the same comfort that we have, right? So that's what I feel that book does for you, is able to talk about hydronics in that aspect. So even though it's been written, almost 30 years ago, I think it was, yeah, it's still relevant
95, yeah.
today. Yeah,
95, 97, somewhere in that time frame. Yeah.
Yep.
It was one of my favorites too, Dave.
Yeah, yep.
But anyway, all righty.
So what's next? What's on the docket next? What we got on the screen next? I know where we're at.
Oh, where we're at? Yes. Where in the world is Carmen Sandiego? Yeah, where's Waldo? Carmen Sandiego. Was it Leland? Who was the other one? Who was the other? Dora the Explorer. That's right.
Dora the Explorer. Yes.
Okay,
yes.
Here we go. This could be the three of us: Carmen Sandiego, Dora the Explorer, and
Waldo.
And where's Waldo? Yeah, I think that could be us next time. Yeah. So where in the world is Jason? Jason's right now out in Denver.
Yes, I'm in Denver. It was almost 100 degrees here today. Pretty hot. Holy smokes. And there's some fires up in the mountains there too. So we've got that haze going. Let's cross our fingers that thing is taken care of soon. Hearts go out to those people. Yeah, next week I come right back to the Rocky Mountains, just on the other side of the Rocky Mountains. Salt Lake City, watch out. We're coming to you with Rocky Mountain Integrated Services, doing full day Radiant class. And we drive to Jackson Hole. I don't even know how far that is, but it sounds like a heck of a drive. And we're going to.
It depends on how much you zoom in on the map.
Yeah, on the map,
yeah,
it
right?
like that long.
Don't pinch the map too much. Yeah, we're going to do another full day training up there. Those guys are some hardy guys up there. High altitude snow melt, heating and cooling loads, and then we're going to end that week in Idaho Falls. I've never been there, and we're going to meet with some wholesalers up there and get them going with our product and give them a little bit more TACO product information. So looking forward to it.
Awesome.
Very good. Very good. All right. And Dave?
I got a lot of stuff going on. Yes, I'm going to stick with the Ozzy reference for myself. So Jason,
you saw that. All right.
Dude, you're the Terminator though, dude.
Yeah, but when you're done with Ozzy, can I have him? Or is he just yours now?
I think I'll have to stay with Ozzy for a little while. Yeah, because that is a great shot. Ozzy. I like that picture. So. So I'm going to be hanging in a couple of weeks. I'm going to be in Ohio and in Pittsburgh for 2 full-day training sessions at the trade show with Famous Supply. So they've got their hydronic symposium, and I am doing a, so to speak, Takeaway After Dark live. So the old sessions of Takeaway After Dark, I've got 7 classes that I'm doing at the Famous Supply convention here at their symposium. Then we've got a couple other things going on in between there, but mostly work related, mostly TACO people. But then I'm jumping up to Guelph, Ontario, for Eden Energy. They have their own hydronic symposium going on, which is a Friday. So I've got a training session that I'm doing there. And then of course there's the factory class in Rhode Island. All right. So I know.
Oh boy.
There, and I'm not sure if JB is going to be there or not. Whether it's
going to be you and me, Dave.
The DJ show or the JB show. I'm not sure.
Is that's not your daughter's wedding time? Is no?
Oh no. My daughter's wedding's no. Daughter's wedding's next week. I was planning on being at the class, but if you don't want me there, Dave,
I remember conversations in the early part of the year whether we were going to start transferring it over to the J&D show, whether it was going to be the JD and J show. Yeah.
I'm not ready yet.
Oh, yes, you are.
Yeah.
I'm going to throw you in the pool, sink or swim.
Totally ready.
There you go.
All right.
Excellent.
So if anybody wants to come to the factory training class, so we've got our 2-day training coming up in September. Hit the website, go to the training tab, register for that class. That is the class that's open for everybody. There's also another one in October as well if you can't do the September class. So Look forward to seeing you guys there. There's still a few open spots. We only hold about 35 spots in the training room. We can push it to more, but we like it around 35. It's nice and comfortable, and we have a lot of fun with it then. Yeah.
Jackie likes 35. I'm good with 45.
Yeah, yep.
Don't mean to interrupt you, John, but Richard McGrath is asking, do we know of any qualified installers in Eugene, Oregon? Who's our rep in the Oregon area?
That's Proctor Sales.
Proctor, let's get a hold of Proctor and see if we can't find somebody.
Yeah, Jason Patterson would know, would be able to find us someone up there, I think. For me, it's good to be the king. I love you. I love you, Dave, for giving me that. It is good to be the king, and I'm glad you recognize that. All right, as king of this as king of this castle, I am going to be heading down to Rhode Island again for Friday for MTTI, the trade school. Then next week, my daughter gets married. My lovely daughter Genevieve. So father of the bride, and that's going to be pretty cool. I'm really looking forward to that. And it's on the day of my daughter's wedding. You come ask me for a favor, I can't refuse. I don't have to follow through, but I can tell you I'm going to do it.
Oh, I can't imagine what you're going through right now, man.
I got you, Richard.
Yeah.
Sorry.
Yeah.
Yep.
I know your girls are a few years older than mine, but never mind.
No, it's going to be great. It's going to be very emotional. And like I said, I'm working on my speech, and I'm.
Are you crying while you're doing your speech?
I every time I get to that point where I get a little weepy, I have to change lanes and say, okay, no, I can't do this. Let's find a way where I don't, and I haven't found that way yet. So I'm going to be. My next step is to ask AI to draft me a speech for my daughter's wedding that I won't cry reading, and I'm okay with that. That's all right. We got FW Web bringing in some people from upstate and western New York, August 26th, 27th. Let's see, in the end of September, beginning of October, actually, just happened today. We're going to be doing some stuff with the Dakota Supply Group in Wisconsin. That'll be me and Jason O'Neill.
Okay, I wasn't sure if that was finalized, so I didn't want to throw it on the page yet.
Yep. We finalized that today. I'm going to be doing the Monday and Tuesday programs, and maybe the Wednesday. Jason will be doing maybe the Wednesday and the Thursday and Friday programs. So this is like a traveling road show that they're putting on, which is kind of crazy, but I'm looking forward to it. It's going to be interesting. So it will be like a carnival, I've always wanted to be a carny, so maybe I'll be a hydronic carny. This will be pretty cool. But anyway,
I do want to. Before we sign off for tonight, I do want to talk about the next couple of classes that we have, episodes that we have coming up. So we have a handful of others that are coming. So we're not, August, we're done. For the rest of the month, it's been a little busy for all of us. So we will be back for Takeaway After Dark. Episode 4 is going to be September 3rd. Still working on the entire program for that. After that, it will be 2 weeks later, so we will get the 17th of September, and then we jump to October 8th, and then October 29th. So we are following that 2-week cadence for the next 2 months. So but we're just working on that still. So we've got a few classes, a few sessions still, 2 a month that we're still putting together. So we will get those up on the Takeo training page. When you take a look at the training page and jump to Takeo After Dark, you will see those sessions there. And of course, just wait for us to show up on Facebook, Instagram, and YouTube. So, I mean, I'm sorry, not Instagram, LinkedIn at the moment. So
there we go. Yeah, and let us know, how do you like this format? If those of you who are watching on LinkedIn, YouTube, or Facebook, how do you like this? Is this working for you guys? It's something we know it's going to take us a while to kind of build an audience, but we're excited about it. I like this. I like this this setup, and questions coming in from all corners. So let us know, how is this working for you? Is this, and is, what kind of cool stuff would you like us? Yeah, there's just a poll that went up on YouTube. Do you like the format?
Great.
I'm going to vote. I do. I guess I can vote, right?
Don't skew the numbers.
I'm not skewing. I can only vote once. How badly can I skew it?
1 out of 3 votes.
Anyway, but yeah, it's just we're hopeful this will be good for you all and give you more ways to digest it. And then, when we cut out all the Dave's parts and we turn this into a podcast, then we'll be we'll be really tight and mean and talk. Yeah, you want to take shots at me about using a paragraph on a sentence? We'll do.
Yeah, right. I fell asleep last time Dave was talking.
All righty, man.
Hey, you guys are awesome. You guys are awesome.
Going there already. Wow.
Yeah, boy. Yeah. Jason's turning on you, Dave. I don't know if you know.
You know what? I've gone through 10 months of hazing from you two. I can give it a little bit back to you, okay?
There you go.
Yeah.
Just remember which one of us is in charge of reviews when you think about who you're giving it back to. I don't mind playing that card. All right, I'm not above that. You're learning, Jason. There's not much I'm above. Okay,
I get it.
If there's a dirty, nasty trick that I haven't thought of, well, then I don't know what to do. You guys never know.
Message received. My superior.
That's all I want. I don't even care if you mean it. All right.
No. Right, you guys are awesome. Thanks for tonight. Great fun.
Right, folks. Thank you all. Thank everybody out there in webinar world and the World Wide Web. We appreciate it. And we'll see you in a couple weeks.
Cheers.
Thanks, gents.
Enjoy, y'all. See ya.